Hello, welcome to day 4, angle of elevation and depression application notes. So today we're going to be using angles of elevation and depression, but we're also going to have non-right triangles because last semester when we did notes on angles of elevation and depression, we always used right triangles, so we were able to use right triangle trig and do SOHCAHTOA. From now on, it's going to be a little bit different. We're going to either have to use law of sines or law of cosines, just depending on what we're given in the problem. So what we're going to do, it says the diagrams you draw are going to represent or will include both right and non-right triangles. For number 1 and 2, we are going to have to set up two equations to solve the problem. So let's go ahead and see what this problem's all about. It says to estimate the height of a tree she wants removed, Mrs. Long sights the tree's top at a 70-degree angle of elevation. She then steps back 10 meters and sights the top of the tree at a 26-degree angle. Draw and label a diagram, find the height of the tree. Okay, so let's say here we have our tree. I'll just draw it as a vertical segment, but we could add some leaves. Okay, so Mrs. Long, she's standing here, she looks at the top of the tree and it's a 70-degree angle. She's able to measure that from the ground. She then steps back 10 feet. So this distance from here to here would be the 10 feet that she steps back, and she again measures the distance, and it is now a 26-degree angle. That makes sense, right? If you're standing next to an object and you're right next to, let's say, a building, and you're looking up at the building and you're right next to it, your angle of elevation is pretty huge. If you start stepping back, the further away from the building you go, the smaller your angle of elevation to the top of the building will be. So the thing we want to find here is the height of the tree. Let's label that X. Okay, so what we have here is we actually have three different triangles. We have this right triangle, and if I look at this right triangle, I don't have enough information to be able to solve for X. I have an angle, but that's all I have. So that's not enough. Here, same thing. I have this angle that's 26. I have a piece of the side of the angle or triangle, but I don't have the entire side. So trig won't work there either, which means that I'm probably going to have to use the third triangle in this picture in order to be able to find X, and that is going to be this triangle. All right, so in this blue triangle, I have a side of 10, I have an angle of 26, but if I put a little bit of effort into it, I'll be able to find some more information in this blue triangle. And at first, it may not be very intuitive, like how to do it, but as you do these problems more, you're going to become accustomed to kind of the pattern that evolves and things to be looking for. So for example, what I see is that I could get this angle right here is 110 degrees because 110 and 70, those two angles are a linear pair, so they have to add up to 180. Then the next thing I noticed that I could get is the top angle of this blue triangle. The blue triangle, the angles have to add up to 180. All triangles, the angles have to add up to 180. So this angle up here is 44 degrees. So now thinking back to the triangle with X that I'm trying to find, this right triangle, if I could find just one side of it, I could use SOHCAHTOA and I could find the measure of X. So again, because I'm used to these, I know for me it's a lot easier to see. I'm going to find the hypotenuse of the green triangle. The hypotenuse of the green triangle is a side of the blue triangle. So now I have to decide, am I going to use law of sines or law of cosines? The way that I always look for it is, do I have an angle on its opposite side? I do. So therefore, law of sines is the way to go. So we're going to write sine of 44 degrees. Whoops, that's not pen. Sine of 44 degrees over 10 equals sine of 26 over y. Cross multiply and solve for y. So y times the sine of 44 is going to equal 10 times the sine of 26. Divide both sides by sine of 44. We're going to get y equals 10 times the sine of 26 over sine of 44. Whoops. Okay, I'm going to have to use this value for the green triangle. So I don't want to approximate this. I don't want to approximate this at all. Instead, what I'm going to do is I'm going to store this value into my calculator. So remember how we do that. We're going to type in 10 times the sine of 26 divided by sine of 44. Let's see what we get. 10 times the sine of 26 divided by sine of 44. I get that y is approximately, and I'm only writing approximate right here to show you, it's 6.3106 dot 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 dot. I'm not going to use an approximation. So what I do on my calculator, I press stow, which has the little arrow, and I'm going to store it to x. Now, in order to differentiate this x from the x in the problem, I'm going to like highlight it or something, or I could make it kind of obnoxiously capital. So I see that this is what x is. Oops, I should just do it like this. I have stored it in. Otherwise, I could just always write 10 sine of 26 over sine of 44 when I'm looking for x. Okay, so now that I have that, if you think about it, here's my little, actually I should draw it in green since it was in green. Here's my green triangle. My whole entire intention was to find the height of the tree, x. I now know this is my big obnoxious x value that I plugged in, 6.3106666 whatever, and this is 70 degrees. So I have to figure out which trig function I'm going to use. The side here is the opposite. This side is the hypotenuse, so that's going to be sine. Sine of 70 degrees equals the opposite, x, over my stored value. It's stored in my calculator of x. Or I could write this ugly fraction expression if I wanted to. So I want to solve for little x, so I cross multiply. Put that over 1. X is going to equal my stored x value times the sine of 70 degrees. On my calculator, I already have that big X stored in there, so I press X, which is to the right of the green alpha button. So X times sine of 70, I press enter, and I get my answer, which is 5.93 meters. Okay, and that's the first problem. Okay, let's take a look at number 2 over here. It says, Annabelle and Rich are setting up decorations for their school dance. Rich is standing in front of Annabelle, and both of them are below a disco ball. The angle of elevation from Annabelle to the ball is 40 degrees, and the angle from Rich to the ball is 50 degrees. The disco ball is 276 feet above the dance floor. How far apart are Annabelle and Rich? All right, so let's draw our picture. We have here a triangle. I'm going to draw a right triangle. The disco ball is up here, right? It's above them somewhere in the gym. Now, if Annabelle is standing here and Rich is in front of her, he has to be somewhere over here. Her angle of elevation is going to be smaller because she's further away from the disco ball. So they said she's 40 degrees, he's 50 degrees. We were also given one more really important piece of information, and that's that the disco ball is 276 feet away or above the ground. And then the question, what we are looking for is how far apart are Annabelle and Rich? That's going to be this distance right here. How far ahead of her is he? So we have to look at this picture and figure out, okay, how are we going to find that distance? That side, y, is not a side of a right triangle. So to get y right off the bat, I'm not going to be able to right away just use, I'm going to use some trig and find y. There's going to be some more work that I have to do. My first instinct always is to find all the angles that I possibly can. So if we have that angle of elevation of Rich is 50 degrees, I could find the adjacent angle, the one next to it, it's linear pair. Those two have to add up to 180, so this angle right here has to be 130 degrees. If that's 130, I know this is 10 degrees. All right, so now that I know that's 10 degrees, 10 and the side that I want, y, they're across from each other. So my mind is thinking, oh, law of sines, because I have a side and an angle opposite it. But it might be law of cosines, I don't know. We have to figure out what else we can find, because this little slanted triangle right here, I don't have enough information to use law of sines or law of cosines. I just don't. I don't have enough. If I had just one side of it, I could use law of sines or law of cosines. So looking at this blue triangle, think to yourself, can I find a side of the blue triangle? The answer is yes. And hopefully everyone's seeing that we can find this red side. If I find that red side, the rest is history. I could do law of sines and find it. So what I'm going to focus on is this right triangle. I'm going to be able to find that red side because it's a right triangle. I know this is 276, this is 50, and let's call this something like, I don't know, P or whatever, okay? To find P, I'm going to have to use right triangle trig. Which function will I use? I have the opposite. I'm looking for the hypotenuse. Okay, so that means I'm going to use sine. So sine of 50 degrees is going to equal the opposite side, 276, over the hypotenuse, which I called P. Put this over 1 and cross multiply. I will get, and I'll move my work over here, P times the sine of 50 degrees equals 276. To get P by itself, I divide both sides by sine of 50 degrees. And now I don't want to type this into my calculator yet unless I store it. Okay, 270 over sine of 50, I could leave that or I could store it. Now, my suggestion is to store it because this is going to be kind of outrageous when I plug it into when I have to use law of sines in a second. It's going to be really hard for me to keep typing that in. So I'm going to put that into the big, like I'm going to again label it like a big X, and I'm going to store it in there. So in my calculator, I press 270 divided by sine of 50. And I got 352.45999999. Stow X, enter, and it's stored. If you're uncertain how to store, please make sure you ask me in class. Also, please make sure you have a graphing calculator because it's going to be really hard for you in this class and future math classes. If you have a scientific calculator, you need a graphing calculator. Okay, so now that we have that red side, and we could call this, capital big X. I wanted to do it in red. Okay, capital big X. We could do law of sines because I have a set. I have an angle and its opposite side. Okay, let's set that up then. Sine of 40 degrees over big X that I have stored in my calculator is going to equal sine of 10 degrees over Y. Let's cross multiply. Y times the sine of 40 degrees equals big X times sine of 10 degrees. Divide both sides by sine of 40. Y is going to equal my stored value of X, sine of 10, divided by the sine of 40. On my calculator, I'm going to press X, sine of 10, enter, divided by sine of 40, enter, and I get Y is approximately 95.22 feet. Okay, in the middle of this problem, I thought to myself, oh, there's another way to do this problem. You don't have to use law of sines at all. You could do trig 2 times. So think about it. We'll go over it in class. I want to show you an alternate way to do this. That's the beauty of math. There's usually more than one way to do things. In geometry, it's even, usually more ways. So think about another way that I could have used the entire right triangle. I could have found the entire base, and then I could have used the little right triangle, the one on the right, and found from R to here, and then subtracted those two. So we'll do that in class tomorrow because I do want you to see, because maybe that's a little bit easier even than what I did here. Okay, let's take a look at the last problem here. It says, a hill slopes at an angle of 12.47 degrees with the horizontal. So that's this green triangle here. That's the hill, and it slants at a 12.47 degree with the horizontal. From the base of the hill, the angle of elevation to the top of a 459-foot tower is 35.48. How much rope would be required to reach the top of the tower to the bottom of the hill? Okay, so what we are looking for is this rope. How much rope would we need? So let's label that X. Okay, you're gonna have similar problems in your homework, and these do tend to give kids trouble sometimes. So that's why we put this in the notes, so to give us practice. Here's the thing, we're gonna drop down this altitude and make this a right triangle. Why? Because now, if I look at this triangle as a whole, I could find the top angle, because I wanna find angles. Without that right triangle, was kind of difficult to do. So now that I know this entire angle here is 35.98, the top one is going to be 90 minus 35.98, aka 54.02 degrees. So what's a little tricky here is we have that this is 459. That is only this side of the triangle. We are looking for x, and then we have this length. So trick to problems like this is to find this angle right here. Well, if the entire thing is 35.98, this piece of it, even though it's written over here, this piece of it is 12.47. To find this inside angle, the one that I did a double arc for, okay, let me erase this red arc. I don't want that. To find this little double arc, what I have to do is 35.98, again, the whole thing, minus 12.47. And when I do that, I get an angle that is 23.1. I'm going to go ahead and redraw this picture because right now I know there's just too much going on with it. Let me actually do a little bit better job. We have this to the top of the tower coming down, going down to the hill. I know this is 459. X is what I'm looking for. My three angles here are 23.1, 54.02, and how can I get the angle across from side X? The angles of a triangle always add up to 180, so it's 102.88. Looking at this picture, I am pleased because I have an angle and its opposite side. That's the law of sines. So sine of 23.1 over 459 is going to equal the sine of 102.88 divided by x. Go ahead, solve that on your calculators. Let me know if you get the correct answer. If not, we will go over it in class tomorrow. The answer I got was 1,140.48 feet. So make sure that you know how to cross multiply, solve for x, use your calculator, type it in. That's really important too to get the correct answer. If you don't know how to use your calculator, you'll never get to the final result. All right, that's it for this day of notes. Thank you so much for watching. Have a good one. Bye.